Section 5.6 is going to be factoring by special products. We have this special formula, difference of two squares. Basically, if you have a squared minus b squared, it's going to factor into this. You're going to get an a plus b, and you're going to get an a minus b. What we have to do is distinguish, well, what is a and what is b. So in problem number 1, what we need to do is, in this first term right here, we want to know what is squared. Well, a is y. In my second term, which is just 100, that's going to be, my b is going to be what squared is 100. So our b is 10. Now all we have to do is plug in a plus b, a minus b. So that's simply a plus b, a minus b. So once we determine what our a and b values are, it's very basic. Alright, so we look at equation 2. We want to know what is a. What square, in this first term, what squared gives me 16? Well, that's a 4. And what squared gives me x squared? So that's my a. Now I need to determine my b. My b is going to be what variable gives me y. What variable squared gives me y squared? So it's going to be a y. Now all I do, once I have my a and my b, I just say a plus b, a minus b. A plus b, a minus b. The next special products we're going to be working with is sum of two cubes, which means addition, right here addition, and the difference of two cubes, which means subtraction. So I have two different formulas right here for these, and they're rather long formulas, so we're going to write them down as we go. When I look at this first problem, we see it's subtraction, so I'm going to be working the difference of two cubes. Okay, so the first thing I have to distinguish is what is cubed. My a is going to be what's cubed in the first term. A is going to be what's cubed here, so that's why I put an x. My b is going to be what raised to the third power gives me 8. What cubed? 2 cubed gives me 8, because 2 times 2 is 4 times 2 is 8. So once you name your a, once you name your b, we're going to write down our factor formula right now, so I'm going to write that down. Okay, I wrote my formula down. Now I'm going to substitute everywhere a is at, I'm going to put an x, and everywhere b is at, I'm going to put a 2. So my answer is going to be x minus 2 times, now a squared means I just have this, which is x squared, plus a times b, that gives me x times 2, which is just 2x, plus, now I need to do b squared. Well, that's going to be 2 squared is 4. So this is going to be my solution for this example. My next example, the first thing I need to do is check for a GCF. Always check for GCF in every problem we factor. So first thing, I see they both have an a in them, so I want to factor out an a. If I take an a out of this term, I'm going to be left with 8b cubed. If I take one of the a's out of here, I'm going to have 27a to the third. Now I stop. This is my GCF and it's taken out, but when I look at my parentheses, I see sum of perfect cubes. This has perfect cubes and this has perfect cubes. So I need to just focus on this portion of my problem and determine my a. Just keep it in blue. My a is going to be what cubed gives me 8? Well, 2 cubed gives me 8, and I need a b. My b is going to be 3 cubed gives me 27, and I also have an a. So I'm going to use my, since it's addition, I'm going to use my sum of perfect cubes formula, and I'm going to stop right now and write this down. Now I wrote my formula down, and I'm only working with this portion right here, so I'm just continuing. My a is going to be 2b plus, now my b is 3a. Okay, now on this I need to do a squared. So that means 2b times 2b is going to be 4b squared minus, now this part I say a times b, so I say 2 times 3 is 6, keep the a and the b. 6ab, make that look more like a 6, and then plus, Now I need to do b squared, which means b squared means 3a times 3a, which is 9a squared. Well, that's that, but I can not forget I got to carry down my GCF. That was the original GCF that I took out. So overall, factored form of this problem is going to be that solution. Alright, my last one, I checked for a GCF. There is no GCF. I see difference. This can be a perfect cube, and this can be a perfect cube. Okay, first I need to see these as cubes, perfect cubes. Well, the first one is fine. That's easy to see the cube. The second one, if I did as y cubed, then that is going to be, I can look at it like that because 3 times 2 is 6. A power to a power, you multiply. So that makes it a little easier for me to tell what my a is and what my b is. My a value is going to be what is cubed in the first term in x. And my b is going to be what is cubed in the second term. So it's going to be y squared is. So once I have my a, once I have my b, then I'm going to substitute it into my difference of perfect cubes. So I'm going to write this part of my formula down now. Okay, now that I have it written down, I have x minus y squared, a squared, a times b. B squared is going to be y to the fourth power. So now I have my solution, and this is using our products, our special products, um, sum of two cubes and difference of two cubes. Okay, when you go back and look at these, I put a triangle by when I used that formula. That's when this is strictly a formula. Okay, and then I put a star when I use this formula. So this is difference of cubes formula, and this is just my difference of cubes formula. So I went back and put those symbols in so you can see where I wrote the formulas and then where my answers are substituted into those formulas.